Hello guys, welcome back to the Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. In today's lecture, we are going to discuss the bending or the flexural stresses in the beam. But before going into the lecture, I would like to request you guys that please subscribe to my new channel. I will given the link in the description. Now coming to our problem, the problem states that find the bending stresses at the mid of the beam. So we have to find out the bending or the flexural stresses at the midpoint of the beam. This is a simply supported beam. The total length of the beam is given. It is 10 meter. We can see here it is 10 meter, and there is a uniformly distributed load of 4 kilonewton per meter acting on the whole length of the beam. And we have to find out the stresses at this midpoint of the beam. We call that it is 5 meter from this point. Because the total length is 10 meter, so the mid of the beam means we will find out the stresses at the 5 meter from the left end or from the right end. So to find out the bending or the flexural stresses, we can use this formula, which is equal to the my over I. Now we know we have to find out the moment. M is here moment. Y is the distance from the neutral axis. It is the distance from neutral axis of your beam section to the point of interest where you want to find out the stresses. And I is the moment of inertia. This I is the moment of inertia of your beam section. So if this is the cross section of the beam, which is 200 millimeter in width, or we can call it 0.2 meter, and this is in height of the beam is 500 meter, or we can call it 0.5 meter. So now to find out the bending or flexural stresses, so we will use this formula. So first thing we need is M, moment. Now to find out the moment, we have to find out the support reaction and shear force diagram, and then we can find out the moment at the midpoint of the beam. For this, I will start the calculation for this beam. So the 4 kilonewton is the total load and the 10 meter is the total length. So the total load acting on the beam is, if you multiply 4 multiply 10, so 40 kilonewton is the load acting, and this load will act at the center of the beam, 40 kilonewton. Now this 40 kilonewton will be equally distributed between the two supports because it is acting at the midpoint. So half load will be shifted to this point A, and half load will be taken by B. So RA comes out to be 20 kilonewton, and also half load will be taken by this 20 kilonewton. So after finding out the support reaction, we can find out now the moment. So how? So here our load is, support reaction is 20 kilonewton. Here the support reaction is also 20 kilonewton. And we want to find the stresses at the midpoint of the beam. So it will be here at the midpoint is 5 meter from this end, 5 meter. So we have to find out the moment at this point. So how to find moment? Either we have to draw the shear force and then we can draw the bending moment, or we can simply take that this load 20 kilonewton is acting in this direction, and this is the force and this is the moment arm from this point up to this point, which is 5 meter. So moment will be equal to the force into moment arm, or 20 kilonewton is the force and moment arm is 5 meter. The distance from this point up to this point is 5 meter. So we will get the moment value equal to the 100 kilonewton meter. So this is our moment value acting at the midpoint of the beam. So, and stress formula is I discussed before, it is equal to the My over I. So M is known to us now. M is now known to us. M is 100 kilonewton meter. Now what is Y? Y, if this is the neutral axis of the beam, this is a rectangle type of the beam. So the neutral axis will lie at the half of this 500. So Y is the distance from where you want to find out the stresses. So the Y we want to take the bending stresses at the top of the beam or at the bottom of the beam. So this is the neutral axis, and y is the distance. Let's suppose we want to find out the stresses at the top section of the beam, so this is our y. So y will be equal to the 500 divided by 2. So it will be 250 millimeter, or we can say 0.25 meter. So our y is also known to us, it is 0.25 meter. Because we want to find the bending stresses, the extreme bending stresses, it will be acting either at the top of the beam or at the bottom of the beam. So the other thing is I, which is the moment of inertia. And moment of inertia of the rectangle is bh cubed divided by 12, because we have a rectangular section here. So b is 200 mm, or we can say 0.2 meter, multiplying with the depth. This is the whole h, which is 500, or 0.5 cubed divided by 12. So we will find our moment of inertia for this beam cross section, which we got 0.02 cubic meter. 0.02 cubic meter. So after finding all these values, we can find our stresses in the beam. So it will be moment is 100, this, and then y is 0.25, and then moment of inertia of the beam, which is 0.002. So we will get our stresses 12,500 kilonewton per square meter, because we use the unit of kilonewton in the force and meter in the unit of the length or in the dimension. So our stresses are 12,500 kilonewton. So now if I draw the stress diagram, so if this is my beam section, I will try to draw it here. So if this is my beam section, so at the top there will be compression stresses, and at the bottom it will be tension stresses. This is positive, and here it will be negative. So the maximum stresses acting here at the top of the beam will be 12,500 kilonewton per square meter, and here at the bottom of the beam there will be tensile stresses, which is also equal to the 12,500 kilonewton per square meter. So here we find out the bending stresses at the mid of the beam. How we can see that it is the mid of the beam? Because our moment we find out was acting at the mid of the beam. And then we find out the stresses at the top, because we took the y distance from midpoint up to the top. So it means we are interested to find out the extreme stresses. So that's why we can say our maximum bending stresses at the mid of the beam are 12,500 kilonewton per square meter. Half of the beam is in compression and half will be in the tension. So hope you guys understand how to find out the bending stresses for a beam, and don't forget to subscribe our channel for daily civil engineering videos. Thank you for watching our video.